Every programming language thinks differently. You know, when I first started my journey into coding, I looked at a screen of code and saw just that. Text, a completely neutral tool. But I quickly realized that is probably the biggest illusion in all of technology.
Some of them are going to give you raw power. Others, they're going to offer you safety. But none of them are neutral. In this explainer, I really want to pull back the curtain on the digital world for us. These languages aren't just syntax. They're basically living personalities. And the one we choose entirely shapes how we interact with the machine.
The ancestors of power. Before we had the sleek, modern apps and the massive cloud servers I use every single day, there were the raw, foundational gods of computing.
Meet C. Born in 1972 at Bell Labs, C is kind of the grumpy grandfather of the coding world. Imagine a construction site where everyone uses pre-made walls, right? Well, C is the guy who insists on making his own bricks from scratch by mixing the sand and the water himself. C forces you to manage the computer's memory entirely by yourself. It's almost like being a chef who cooks the meal, but also has to personally wash every single plate, scrub the floors, and count every grain of salt. And if you forget, the whole kitchen explodes or, your computer blue screens. He doesn't have a delete button for mistakes. But because of this raw, absolute manual control, C is incredibly fast. It's the language breathing life into the Windows OS on my laptop, NASA's Linux servers, and even the tiny chip inside a microwave.
But as you can imagine, by the 1980s, projects were just getting too big. Building software with C started to feel like building a massive, sprawling city using only toothpicks. So C++ was born. If C is a manual transmission car, C++ is a Formula One racer with 1,000 extra buttons on the steering wheel. It is the ultimate power tool for high-stakes performance, where every single microsecond and every single pixel actually counts.
And its real superpower? Something called object-oriented programming. Instead of writing manual code for every single tree in a massive digital forest, you just create a blueprint of a tree. Then you can copy-paste to pop out thousands of them instantly. This capability makes C++ the undisputed king of breathtaking gaming worlds. So when I'm exploring the sprawling, neon cities of Cyberpunk 2077 or dropping into a massive match in Fortnite, I'm experiencing the sheer, complex power of C++. It's a golden sword, assuming you can actually master its many demanding rules. Builders of the digital society. As we moved into the mid-90s, the entire world changed. We weren't just building standalone programs anymore. We were building the web, and we were structuring massive corporate enterprises. We needed builders for an entirely new digital society. When looking at the internet, I discovered two completely unrelated personalities that totally shaped it. On the left, we have Java. And on the right, JavaScript. Now, I used to think they were related, but honestly, it's like the difference between a car and a carpet. Java is the strict school principal who deeply values rules. Why? Because he wants to keep everything safe. Back then, code written for one computer just wouldn't work on another, so Java arrived with this massive catchphrase, write once, run anywhere, acting as a universal translator. JavaScript, on the other hand, is the chaotic artist with flexible, wildly unpredictable logic.
Let's stick with Java for just a second. It absolutely will not let you touch the scary parts of the computer directly. It uses a garbage collector. Think of it as a robotic vacuum cleaner that just follows you around cleaning up your coding messes automatically so the system doesn't suddenly crash. Because it's so incredibly safe, big banks, giant enterprise companies, and the entire Android app empire absolutely love it. It is, without a doubt, the most reliable bodyguard in the business.
But what about our chaotic artist? JavaScript was literally created in just 10 days. At first, it was kind of seen as a joke, just a tiny language for making annoying pop-ups or flashing text on early websites. Today, though, it has evolved into the heavy-lifting soul of the internet. It might have some really weird math quirks, like adding a number to a word and just giving you a weird soup of text, but it's the only language that natively runs inside every single web browser on Earth. If a website moves, updates, or chats with you without refreshing the page, JavaScript is doing that work. TikTok, Instagram, YouTube, they all completely rely on this chaotic, beautiful artist.
Now, what if we have data? Mountains of it. Imagine a library with 1 billion books just thrown on the floor in a massive, messy pile. How in the world do you find one specific name on page 42? Well, you call SQL. Pronounced SQL, it is the silent librarian of the digital world. You don't tell the computer how to search, you just tell it exactly what you want. It's the magic search bar working completely invisibly behind my Amazon product searches, video game high scores, and my bank balances. If data is the new oil, SQL is the high-tech drill getting it out of the ground.
And then I found the language that really helped build the social web, PHP. Some people say it's a bit old-fashioned, but it's honestly like a 30-year-old local pizza shop. It's still there because the pizza is great and it never lets you down. Before PHP, making a website save a user account was like building a rocket ship. PHP made it as easy as playing with Legos. It's the veteran survivor that Mark Zuckerberg used to build the very first version of Facebook in his dorm room, and it still powers Wikipedia and nearly half the websites I visit today. It simply wants to get the job done.
The modern architects. Because, as we know, technology never actually stops evolving. Today, we need highly optimized, futuristic languages to power global cloud scaling and the massive artificial intelligence revolution.
For a really long time, making iPhone apps meant using Objective-C, which kind of felt like writing a book on an old rusty typewriter. Then, Swift arrived. It's like switching to a high-tech iPad with a seamless stylus. Swift is the polished designer. It's built to be safe by design, acting like a car that automatically hits the brakes before you hit a wall. It catches mistakes while you're actually typing, keeping iPhone apps sleek, crash-free, and perfectly optimized so they don't drain your battery in 10 minutes flat.
Now, as a beginner, I was really looking for a friendly genius. If coding were a sport, Python would be a relaxing walk in the park on a beautiful sunny day. Its creator, Guido van Rossum, wanted a language that was as easy to read as a comic book. So instead of a billion confusing curly brackets and semicolons, Python uses simple, polite spaces. It's clean, it's elegant, and it is the absolute best friend a beginner could ever ask for when writing their very first program.
But honestly, don't let that friendliness fool you. Python is very much the brain behind the curtain of the future. It might move a little slower than C++, but it carries an infinite library of magical tools. When I ask ChatGPT to write a poem, or I watch a deep fake, or I get a scarily accurate movie recommendation from Netflix, Python is the one doing the heavy thinking. Even NASA uses it to analyze complex space data. It is the undisputed king of artificial intelligence and data science.
Meanwhile, over at Google, their brilliant engineers had a completely different problem to solve. They were so tired of waiting for giant, clunky systems to finish working. They needed something fast, like C++, but as readable and clean as Python to handle massive cloud systems. So they built Go. Its absolute superpower is concurrency. Instead of one person slowly and stressfully trying to serve 1,000 customers, Go is like a manager instantly hiring 1,000 tiny, super-fast robots to serve everyone simultaneously. It is the efficient builder, the worker bee king managing the massive, invisible scale of apps like Google Photos without ever lagging behind the scenes. So for about 40 years, programmers were trapped by this really painful choice. You had to choose. Do you want a language that is incredibly fast, like C++, or do you want a language that is totally safe from crashes, like Java? You simply could not have both. It was impossible. And then, almost out of nowhere, Rust appeared. And it basically said, watch this. Rust is the strict but brilliant master architect. It will absolutely not let you start building until it has checked every single bolt and screw in your blueprint. It has this incredible feature called the borrow checker that prevents 99% of the memory security holes that hackers usually exploit. Now, it is notoriously difficult to learn. It's kind of like learning to fly a fighter jet instead of throwing a paper airplane. But once you master it, you create software that is both lightning fast and entirely unhackable.
So when I look at this whole landscape of modern titans, the roles become incredibly clear. Python is the friendly genius for AI, Swift is the polished designer for Apple, Go is the efficient builder for the cloud, and Rust is the master architect for unhackable systems. Because of Rust's absolute, undeniable safety, the smartest minds at NASA, Microsoft, and the Linux team are currently making the massive switch. Rust is essentially the guardian of our future, ensuring our increasingly digital hospitals, banks, and power grids remain totally safe from attacks.
Shaping how you think. Stepping back from the actual code for a minute, I really had to ask myself, why does this actually matter as I look at these tools for the very first time?
It's because coding isn't just about memorizing syntax. It's actually about adopting an entirely new worldview. The language we choose literally shapes the way we think. When we learn C, we learn to think in absolute memory and raw control. When we learn Python, we think in elegant data and seamless automation. When we learn Rust, we think in structural precision and bulletproof security.
And the way you think, well, that shapes exactly what you build. By stepping into these different digital minds, I'm not just learning to type commands into a glowing terminal. I am learning entirely new ways to solve the world's most complex problems. It's like uncovering hidden knowledge. The digital future is vast, and these incredibly powerful tools are sitting right in front of us. So,
Which superpower will you choose first? Because I'm ready to pick a language, step into the machine, and finally write my first line of code.